This video gives an introduction to function composition. Function composition is defined as follows. Given two functions f and g, the composite function, which is denoted f with an open circle followed by a g, and defined by f composed with g of x equals f of g of x. That sounds much more complicated than it is. Let's take a look at this picture over on the right. Function composition, what's happening is that two functions are acting on an original x value. I oftentimes think about it as an assembly line. One person gets a piece of metal and they bend it into a certain shape, and then they pass it on to the next person, and that person's job is to paint the piece of metal, and then they pass that on to the next person whose job is to drill a hole in it, or something like that. So an original piece goes in, and then a different product is coming out. That different product is handed off to the next person, and again, a different product comes out. So taking a look at this diagram, I have two functions. The function f, which is equal to x squared, and then a function g, which is equal to x plus 1. We start by inputting the number 3 into our function f. Well, function f squares the x value. So if we plug 3 in, we'll square it, and it's going to output the number 9. That output of 9 is then passed off to the function g. And function g takes an x value and then adds 1 to it. So plugging 9 in, g is going to add 1 to it and output 10. Therefore, g of f of x is equal to 10. An input value went into one function, something got outputted, that output went into the next function, and something else came out. Let's see how we would do that with equations. Let g of x be equal to 5x plus 1, and h of x be equal to the cube root of 9 minus x. We want to find g composed with h of 1, and h composed with g of negative 4. So g composed with h of 1. I think one of the most important parts is just rewriting it properly after the given notation. This is the same as g of h of 1. And I like to color code it because I feel like I can see better. So g composed with h of 1 is the same as g of h of 1. We always start on the inside. That's order of operations, innermost parentheses. So we start on the inside and we want to find h of 1. This is that original input being put into the first function. Plugging 1 into our function h, that's the cube root of 9 minus 1, which is the cube root of 8, which is equal to 2. So that first function has now outputted the number 2. Now we take that 2 and we plug it into the second function, g. So just in my notation, I'm taking this blue would be better. All right, I'm taking this 2 and I'm just plugging it into the other highlighted blue where h of 1 is, and that gives us g of 2. G of 2 is going to be equal to 5 times 2 plus 1, which is equal to 11. That's going to be our final answer. G composed with h of 1 is equal to 11. Let's try the next one. H composed with G of -4. The initial rewrite is really important. This is the same as H of G of -4. We'll start with the inside. We need to find G of -4. It's going to be 5 times -4 plus 1. -20 plus 1 is a -19. That's our first output. Now we're ready to plug that output into our second function. So we're going to be finding H of -19. H of -19 is equal to the cube root of 9 minus -19. That's equal to the cube root of 9 plus 19, which is equal to the cube root of 28. We try to simplify this cube root, but there's not a perfect cube that's a factor of 28. Therefore, H composed with G of -4 is the cube root of 28.